This lesson is on solving systems of linear equations by substitution. So this will be an algebraic method which will allow you to solve linear equations and get any answer, not just the answers that you can graph nicely, but any algebraic answer. So it's going to involve taking part of one equation and plugging it in algebraically into the other, thus forcing both equations to work together, giving you a result. And remember, we have three possible results: either a single solution, a point, or no solution, or we could also have the option of the lines being the same, which gives us all possible solutions, solutions that satisfy the line equation. So recall, solutions that satisfy the line equation is when your line is the same. You will soon notice what happens algebraically to equations when we substitute them together and the solutions are all the same. No solutions was when the lines were parallel. They never ever touched, so nothing ever worked. And one solution was when you had one single answer. Let's take a look at some examples of using substitution. This will give you a better idea of what substitution is. In the first lesson on solving linear equations, you were shown to take both equations, graph them, and see where they meet. Essentially, this is what we do to solve equations. However, if we want a more precise answer, a more algebraic approach, we basically want the truth statement of the first equation to work in the second equation. So, at this stage, what we can do is we can choose one of these equations, either one. Your first step is to solve for one of your variables. Now, it really doesn't matter which one, just one of them. You could pick the x, the y, the x, the y. Doesn't matter. However, I like to choose the easiest one to solve for because it's the least work. So the one that I see to be the easiest is x in the first equation. Subtract 2y from both sides, giving us negative x equals negative 2y minus 2, and divide everything by negative 1, giving us x equals 2y plus 2. Now, what's happening is that we have x as being the same as 2y plus 2. What we can do is we can take the 2y plus 2 and replace it with any x value in the other equation. So now in the second equation, we can plug in 2 times x, and that x has been now confirmed to also be a 2y plus 2, plus 3y equals 11. So all we've done is we've taken one variable, solved it, and we're plugging it into the other equation so that we now have an equation that uses both equations, but it's in one variable. Now we can solve this. The second step was to substitute the new expression into the other equation. Make sure you put it into the other equation, because if you put it back into the same equation, you'll end up with, oh yeah, all of the answers work, of course, because you're putting the same equation into the same equation. You want to make sure that some of the truth from one equation is put into the other equation to therefore further solve and find what works for both. Let's expand. We get 4y plus 4 plus 3y equals 11. Combine like terms, you get 7y plus 4 equals 11, which gives us 7y equals 11 minus 4, which is 7, and y therefore divided by 7 equals 1. We have now one part of the point which we need. So since we have the y value, we now need the x value. But hey, we had solved for one of our x's up here. So we could see that x is equal to 2 times the y plus 2. Let's plug in our 1, and that gives us 2 plus 2, which is 4. So our final answer would be 4, 1. Let's recap what we did. We took one equation. You can pick either one and solved for one variable, and you can pick either one as well. Pick the easiest one, solve for it, and plug it back into the other equation so that you have only one variable which you know how to solve, and you can solve for the other variable, leaving you with an answer. If you like, you can check your work. And we've looked at an example in the previous lesson where you can plug in your x and your y into both equations to see if it works. Here's another one. So they want us to use substitution. First, let's choose which variable is easiest to solve for. Hey, this one's already solved for a. Let's keep it that way. So we know that a is equal to negative 2b minus 5. We can take it from the second and put it into the first by replacing our a with negative 2b minus 5, because we know that that should be true based on the solution, the system that has been given. So that gives us 3 times negative 2b minus 5, which was our a, plus 6b equals negative 15 from the first equation. We've just replaced our a with what it was in the second equation that was given. Now you can solve this as before. Negative 6b minus 15 plus 6b equals negative 15. Hey, our negative 6b's cancel out when we collect our like terms, leaving us with negative 15 equals negative 15. So what does this mean? Well, everything is always going to work because negative 15 is always equal to negative 15. Therefore, all A and B pairs that satisfy at least one of these equations should work. Well, that must mean that the first equation is really just the same as the second equation, and you could check that by solving them. But what this tells us is that the solutions satisfy one of these equations, and they are the same equation. So you could just write, pick one, whichever one you'd like, and that represents the solution set. Let's take a look at this example. In this example, we can also choose one variable in one equation to solve for. However, that variable has to be altogether on its own. So notice in the first equation, we've got x's and y's on both sides. So let's pick x or y in this equation and solve for it. So let's solve for y. Let's add y to both sides. And note that it really doesn't matter which one you solve for. You could solve for x or y in this equation as well. I've just chosen y. So we've got 2x, we've added y to both sides, we've got equals x plus 2y. Well, we still need to get y by itself. Let's subtract x from both sides. We've got x equals 2y. Okay, well, hey, we don't need to go any further. If we solve for y, then you'd have 1/2 x, and that wouldn't be very nice to work with for most of you, so keep it as, hey, x equals 2y. So since x equals 2y from the first equation, we can plug that into the second equation and continue solving. So we've got negative 2 times x, which is also 2y, plus 4y equals 6. Let's continue. That gives us negative 4y plus 4y equals 6. Whoa, negative 4 plus 4 is 0. 0 equals 6. True or false? For sure this is false. So what this means is we have no possible way of making this work. Therefore, it is a no solution question. There is no solution that will work. Let's take a look at this beast. I want to provide you with one of these examples because I want you to see how you would take something more complicated and what you would do with it. So, recall that when you have denominators in an equation, you can use the fact that you have an equation and you can multiply every single term by the lowest common denominator, which in this case is 6. When you multiply everything by 6, you'll see some cancellation happening. And so you can expand. So let's take a look what this first equation tells us. 2 times 6x minus 1 minus 2 times 5, which is 10, equals 3 times 3y plus 1. So we can expand to give 12x minus 2 minus 10 equals 9y plus 3. Let's combine as much as we can. We'll get our x and y on one side. It is difficult right now to decide what to solve for until we have the other equations solved out. So let's just rearrange this a little simpler here. This is going to be 12x minus 12 equals 9y plus 3. So let's just get our numbers onto one side, and let's add 12 to both sides, leaving us with 12x is equal to 9y plus 15. In the next example here, we could multiply every single term by the lowest common multiple, which is 8. You could simplify, leaving you with 2 times 1 plus 5y plus 2 times x plus 3 equals 4 times 17. And 4 times 17 is 68. So that leaves you with 2 plus 10y plus 2x plus 6 equals 68. And let's put some things together here. We've got 8 on this side. We can subtract 8 from both sides. We get 10y plus 2x equals 60. So, let's get this one by itself because it looks like we could divide everything here by 2 and get x by itself. So we'd have 2x is equal to negative 10y plus 60, and we could divide everything by 2, giving us x is equal to negative 5y plus 30. So if x is equal to negative 5y plus 30, we could plug that back into the other equation and see what happens. That'll leave us with 12 times x equals 9y plus 15, and our x was negative 5y plus 30 from the other equation. That leaves us with negative 60y plus 12 times 30, which is 360, equals 9y plus 15. Let's get our y's together. So let's say add 60 to both sides. So you get 69y equals 360 minus 15, which is 345. Now let's see what 345 over 69 gives us. And that actually nicely gives us a 5. Note that sometimes you can simplify it into a fraction if needed, but in this case it simplifies to a whole number. So y is 5, and therefore we can plug that back in to get x, and x is negative 5 times 5 plus 30, which is 30 minus 25, which is also 5. Therefore, 5, 5 should be the answer to this very complicated question. Make sure when you are doing these types of problems that you do plug it back in to the original equation, because that will help you check if you haven't made any errors on the way. You might be applying the exact technique that you should be, but you might be missing a number. There are a lot of places for mistakes in these types of problems. So let's just see if it works in the first equation. If we plugged in 5s for all our variables, because x and y are both 5, let's see what the numerator would give us. So this would be 6 times 5 is 30 minus 1. So 30 minus 1 would be 29 thirds minus 5 thirds should give us, and 3 times 5 plus 1, 3 times 5 plus 1 is 15 plus 1 is 16 over 2, which is 8. So what's 29 thirds minus 5 thirds? 29 minus 5 is 24 thirds. 24 thirds is equal to 8, so that works. Plug it into here. 1 plus 5 times 5 is 26 over 4. 5 plus 3 is 8 over 4. So 26 plus 8 over 4 gives us 34 over 4. And let's see, does that simplify to 17 over 2? Yes, it does. So we have checked that 5, 5 is a solution, is the only solution to this system of equations.